Welcome back to KrossUSA channel. From the forests of Europe to the hearths of America, witness the incredible machines that transform raw timber into the firewood that's warmed our homes for generations. Let's see how it's done. When winter's bitter cold settles across America's northern states, the demand for firewood becomes a matter of survival and comfort. But before that cordwood reaches your hearth, it begins its journey in the forest with remarkable machines like the Komatsu 931.1 harvester, a technological marvel that's been revolutionizing timber operations since its introduction. NTHE Komatsu 931.1 represents the pinnacle of Swedish-Japanese engineering collaboration. This 8-wheel giant weighs in at approximately 19 tons and is powered by a robust 210 horsepower Mercedes-Benz engine, giving it the muscle to navigate challenging terrain while maintaining fuel efficiency that would have seemed impossible to loggers from generations past. What makes the 931.1 truly special is its harvesting head, the business end of this operation. Equipped with a high-performance harvester head, typically the Komatsu S92 or similar models, this machine doesn't just cut trees, it processes them with surgical precision. Watch as the operator guides the machine to a standing tree. The head's powerful feed rollers, capable of gripping, stems up to 24 inches in diameter, clamp onto the trunk with hydraulic force exceeding 35,000 pounds. NTHE cutting process is poetry in motion. A chainsaw bar, running at speeds up to 7,000 feet per minute, slices through the base in mere seconds. But here's where it gets fascinating. As the tree is felled, those feed rollers immediately take control, pulling the entire tree through the harvesting head. Delimbing knives, mounted in a circular pattern around the head, strip away branches as the trunk passes through, leaving clean timber behind. NTHE operator then activates the measuring system, a computerized length gauge that uses sensors to measure the log with accuracy down to the centimeter. With a simple control movement, the head's top saw cuts the log to exact specifications, whether that's 8-foot cordwood lengths or longer saw logs. The Komatsu's cabin, pressurized and climate-controlled, keeps the operator comfortable in any weather, a far cry from the manual lumber camps of yesteryear where men worked through brutal winters with nothing but axes and cross-cut saws. This single machine can process 200 to 300 trees in a working day, replacing the labor of dozens of traditional loggers. Yet it does so with remarkable precision, reducing waste and ensuring maximum utilization of every tree harvested. For operations supplying firewood to communities facing harsh winters, the Komatsu 931.1 isn't just equipment, it's the critical first link in the chain that keeps homes warm when temperatures plummet. Once logs leave the forest, they need to be transformed into usable firewood. And few machines do this better than Austria's Pro K650, a firewood processor that's earned legendary status among heating professionals across Europe and North America. NTHE process begins at the in-feed conveyor, where logs are placed horizontally. The conveyor system, driven by a 22 horsepower engine, automatically feeds logs toward the cutting station at controlled speeds. Here's where generations of European woodworking knowledge shine through. The K650 uses a circular saw blade rather than a chainsaw, a design choice that dates back to traditional alpine sawmills. This 24-inch carbide-tipped blade, spinning at 800 RPM, delivers cleaner cuts with less waste than chain systems. And as each cut is made, the measuring system, adjustable from 10 to 20 inches, ensures consistent lengths perfect for standard wood stoves and fireplaces. The cut rounds then drop onto the splitting station, where a 16-ton hydraulic ram drives them against a multi-way splitting wedge. This wedge configuration, typically splitting rounds into 6 or 8 pieces, mimics the natural grain lines of the wood, reducing splitting resistance and power consumption. NFOR families who remember when preparing winter wood meant weeks of manual labor with axes and mauls, the K650 represents not just technological progress, but liberation, allowing small operations to serve their communities efficiently, while preserving the tradition of wood heat that's warmed American homes for centuries. In the small town of Nowogrodzki, Poland stands a testament to American manufacturing ingenuity serving European industry. A complete Wood-Mizer industrial sawmill system producing pallets for Meblohit, an operation that perfectly illustrates how modern sawmilling has evolved from the steam-powered mills of the 1800s. Wood-Mizer, founded in Indiana in 1982, revolutionized portable sawmilling with their thin kerf blade technology. The system installed at Meblohit represents their industrial-scale evolution, centered around their twin-band resaw and optimized production line capable of processing thousands of board feet daily. NTHE process begins at the primary breakdown saw, typically a Wood-Mizer WM1000 or similar industrial head rig. Raw logs, usually pine or spruce common in European forestry, are loaded onto the mill's hydraulic log deck. What makes Wood-Mizer's approach distinctive is their use of thin kerf bandsaw blades, typically just 0.045 inches thick, compared to circular saws that can waste over a quarter inch per cut. Over thousands of cuts, this difference translates to significantly more usable lumber from each log, a principle that old-time sawyers would have appreciated deeply. NTHE head rig operator working from a computerized control station makes the critical first cuts. Modern laser scanning systems analyze each log, suggesting optimal cutting patterns to maximize yield. The primary breakdown typically produces cants, squared-off sections that will become the actual pallet boards. These cants then travel via a sophisticated conveyor system to the twin-band resaw, where two vertical bandsaw blades simultaneously slice the cant into multiple boards of precise thickness. Here's where the system's intelligence truly shines. Each board passes through an automated grading station using optical sensors and computer vision. Boards meeting pallet grade specifications, typically 3/4 inch to 1 inch thickness, are sorted and directed to the pallet assembly area. Boards with defects are automatically diverted to secondary products or chip production, ensuring zero waste. NTHE edger stations, positioned strategically along the line, trim each board to exact width specifications using computer-controlled positioning. This precision is crucial for pallet manufacturing, where standardized dimensions ensure compatibility with forklifts and automated warehouse systems worldwide. And Meblohit's system includes Wood-Mizer's automated stacking and bundling equipment, where finished pallet boards are organized by dimension and moisture content. The entire operation, from raw log to finished pallet component, happens in a continuous flow that would seem like magic to sawyers from the great lumber boom of the early 20th century, when such mills employed hundreds of workers doing manually what a dozen operators now accomplish with greater precision. This level of automation doesn't just increase productivity, it ensures consistent quality and safety, producing the standardized pallet components that keep global commerce moving. Each pallet board that exits this system carries within it centuries of woodworking knowledge, now executed with modern precision that benefits both manufacturer and end user. In the Appalachian foothills of West Virginia, Weyerhaeuser operates one of North America's most sophisticated-oriented strand board facilities, a plant that transforms whole trees into engineered wood products that have revolutionized modern construction since OSB's commercial introduction in the 1970s. Logs arrive at the plant and immediately enter the debarking drums, massive rotating cylinders where friction removes bark without wasting valuable wood fiber. NC lean logs then proceed to the stranding stations, where specialized stranders, essentially industrial-grade planers with knives, slice the. This stranding process is crucial. These dimensions provide optimal structural properties when the wafers are later oriented and bonded. NTHE strands travel through massive rotary dryers, reducing moisture content from 50% to approximately 6%. This drying phase, taking place in drums the size of small houses, uses controlled heat around 550 degrees Fahrenheit. Dried strands then move to the blending stations, where they're coated with phenol formaldehyde resin and wax, adhesives that create OSB's remarkable strength and moisture resistance. The magic happens at the forming stations. Computer-controlled orienters align the outer layer strands parallel to the panel's length, while core layer strands run perpendicular, creating a cross-laminated structure that mimics plywood strength at lower cost. These formed mats then enter the continuous press, the engineering marvel stretching over 100 feet long, applying 600 pounds per square inch of pressure at temperatures reaching 400 degrees. The combination cures the resin and bonds the strands into solid panels in mere minutes. Finished panels are trimmed, graded, and bundled for shipment, destined for residential construction across America, a modern material born from innovation and efficiency. From Finland, where winter heating isn't just tradition, but absolute necessity, comes the Narva S23 Firewood harvester, a specialized machine that perfectly bridges mechanical harvesting and retail-ready firewood production. NTHE S23 represents Finnish practicality at its finest. The harvesting head grips standing trees up to 8 inches in diameter, cuts them at ground level, and immediately begins processing. What distinguishes the Narva system is its integrated approach. As each tree is felled, the feed rollers pull it through delimbing knives that strip branches cleanly. The log then passes through a measuring wheel that precisely tracks length, and a powerful hydraulic chainsaw makes cuts at preset intervals. NBUT. Here's where the system becomes truly innovative. The cut rounds don't simply drop to the ground. Instead, they're directed into an integrated splitting mechanism featuring a hydraulic wedge that quarters each round in a single stroke. This four-way split produces pieces that dry faster and burn more efficiently than whole rounds, a detail that matters greatly when you're heating through 5 months of winter. NTHE split firewood then travels via conveyor directly into an automated bagging station, often a Tajfun or similar system. These baggers use breathable mesh bags that allow continued drying while providing a clean, retail-ready package. The bagging process is remarkably efficient. A pneumatic system holds each bag open, while the conveyor deposits precisely measured amounts of firewood, typically 15 to 20 pounds per bag. In the Scandinavian forests where timber harvesting evolved into a precise science, the combination of Swedish innovation creates something truly remarkable. A JPS X3M processor head mounted on a Hudig 1260 backhoe loader, equipped with an indexator tilting rotator. This system represents the culmination of decades of Nordic forestry engineering, each component contributing unique capabilities to create a versatile timber processing powerhouse. Now, mounted at the end of the Hudig's 20-foot boom, sits the indexator rotator, a hydraulic marvel that might seem like a simple swivel joint, but represents sophisticated engineering. The indexator IR series rotator provides both continuous 360-degree rotation and independent tilting capability of 45 degrees in either direction. This dual-axis movement is crucial. It allows the processor head to approach logs from any angle, maintain optimal cutting geometry, and position cut pieces precisely for stacking or loading, all without repositioning the entire machine. NTHE JPSX 3M processor head itself is where Finnish engineering expertise truly shines. Manufactured by Jarvinen Punergia-Palvelu, this processor head weighs approximately 100 pounds and handles logs up to 16 inches in diameter with remarkable efficiency. NTHE operational sequence demonstrates the system's sophistication. As the operator maneuvers the Hudig to a log on the ground, perhaps a stem that was previously felled by a separate harvesting operation, the indexator rotator allows precise positioning without moving the base machine. The processor head's hydraulic grapple arms, powered by independent cylinders generating over 10 tons of clamping force, secure the log firmly. Here's where the integrated measuring system becomes invaluable. As the feed rollers, aggressive, carbide-toothed drums, pull the log through the head, a sophisticated measuring wheel tracks exact length with digital precision. The operator, working from Hudig's climate-controlled cab with joystick controls, watches a digital display showing real-time measurements. When the desired length is reached, whether that's 8-foot pulpwood, 16-foot saw logs, or specific firewood dimensions, a simple button press activates the chainsaw mechanism. NTHE cutting action itself is fascinating. Unlike traditional chainsaws held by human hands, this system uses hydraulic pressure to drive the saw bar through the log, while the feed rollers maintain constant tension on both sides of the cut. This controlled approach produces remarkably square cuts with minimal fiber tearing, even in tough hardwoods like oak or ash. NTHE delimbing capability, while secondary to cutting, shouldn't be overlooked. The head features fixed delimbing knives, hardened steel blades positioned around the circumference that strip branches as the log passes through. For firewood operations, this means logs arrive at the cutting station already clean, ready for immediate processing into cordwood. NFOR operations supplying firewood to communities preparing for harsh winters. This JPS Hudig indexator combination represents an ideal balance, powerful enough for production-scale operations, yet nimble enough for selective harvesting in managed woodlots. It's technology that serves tradition, enabling sustainable firewood production that keeps homes warm while preserving forest health for future generations. From the birch forests of Finland comes Ponsse, a company whose very name has become synonymous with cut-to-length harvesting excellence. The Ponsse Ergo, equipped with the new H7 harvesting head and C5 active crane, represents the cutting edge of what's possible when decades of forestry knowledge merge with 21st century technology. NTHE Ergo itself is Ponsse's mid-range harvester, introduced in 2012 to bridge the gap between smaller machines and heavy-duty harvesters. Weighing approximately 18 tons and powered by a 210 horsepower Mercedes-Benz engine meeting strict emission standards, the Ergo is designed specifically for the demanding conditions of Nordic forestry, where temperatures can swing from -40 to +80 degrees Fahrenheit. NBUT, it's the new H7 harvesting head that truly captures attention. This third-generation head represents Ponsse's response to decades of operator feedback. Capable of handling trees up to 26 inches in diameter, the H7 features 4 feed rollers instead of the traditional 2, a design innovation that provides superior grip and more consistent feeding, particularly critical when processing the dense hardwoods that make premium firewood. NTHE roller configuration is ingenious. The feed rollers are positioned in a diamond pattern, with 2 providing primary grip, while 2 provide lateral stabilization. Each roller is independently powered and can develop over 20,000 pounds of feed force. This matters enormously when processing crooked or knotty trees, the kind of timber that challenges lesser machines but represents valuable firewood resources. NTHE H7's delimbing knives are another evolution. Rather than fixed blades, Ponsse employs spring-loaded knives that automatically adjust pressure based on stem diameter and branch size. This adaptive system reduces damage to the stem while ensuring clean delimbing. Important when producing saw logs, but also valuable for firewood production, where excessive bark inclusion can affect burning characteristics. Now, let's discuss the C5 active crane, a technological marvel that might not look revolutionary, but represents a quantum leap in operator ergonomics and precision. The active designation refers to PONSSE's electronic boom control system that uses multiple sensors throughout the crane structure. These sensors constantly monitor load, position, and movement, feeding data to a central processor that makes micro adjustments to hydraulic flow hundreds of times per second. What does this mean in practice? The crane moves more smoothly, positions more precisely, and, critically, reduces the physical strain on operators. In traditional harvester cranes, operators must constantly compensate for momentum, load swing, and terrain angle. The C5 active crane does much of this compensation automatically, allowing operators to focus on the harvesting process rather than fighting the controls. NTHE cranes reach approximately 33 feet, and lifting capacity of over 4,000 pounds at full extension allow the Ergo to maintain a stable working position while accessing a wide cutting area. This reduces the time spent repositioning the entire machine, a factor that significantly impacts daily productivity. In the heart of Germany's Black Forest region, where sawmilling traditions stretch back centuries, Cretzer manufactures precision sawmills that embody German engineering philosophy, robust construction, precise tolerances, and longevity measured in decades rather than years. The SSM 800 represents this tradition perfectly, a horizontal bandsaw mill designed specifically for processing firewood and smaller sawlog operations. NTHE heart of the system is a 5.5 horsepower electric motor, driving a 10-inch wide bandsaw blade through precision machined wheels, a combination that delivers smooth, accurate cuts with minimal waste. What distinguishes Kretzer's approach is attention to the fundamentals. The blade guides, often overlooked components in lesser mills, use roller bearings rather than simple blocks, reducing friction and extending blade life significantly. The log bed features heavy-duty steel construction with adjustable supports every few feet, preventing the sagging that causes wavy cuts in long logs. NTHE carriage system utilizes a rack and pinion drive, giving operators precise control over feed speed. This matters enormously when sawing different species. Dense hardwoods like oak require slower feed rates than softer pines, and the ability to adjust on the fly prevents blade damage and ensures clean cuts. A digital scale integrated into the carriage shows exact board thickness, allowing operators to maximize yield from each log. From the mountainous regions of northern Italy comes Sierra, a manufacturer specializing in portable sawmills designed for the challenging conditions of alpine forestry. The Montana MD90 represents their answer to a question that's plagued sawyers for generations. How do you bring mill-quality precision to remote timber stands, where transportation costs would make conventional sawmilling uneconomical? NTHE MD90's design philosophy centers on rugged portability. The entire mill, including the cutting head, carriage system, and controls, mounts on a steel frame measuring approximately 20 feet long and weighing just under 2,000 pounds. This compact footprint means the mill can be towed behind a standard pickup truck and positioned in locations where larger mills simply cannot go, a crucial advantage when processing timber in woodlots accessible only by forest roads. N-Power comes from a 20-horsepower diesel engine. Sarah's choice of diesel over gasoline reflects European preference for fuel efficiency and torque characteristics better suited to sustained heavy cutting. The engine drives a 12-inch bandsaw blade through a precision-machined flywheel system that maintains consistent blade speed even under varying load conditions, a feature that separates professional-grade mills from consumer equipment. NTHE cutting capacity impresses. Logs up to 30 inches in diameter and 16 feet in length can be processed, dimensions that handle the majority of timber found in mixed hardwood-softwood forests. The vertical blade configuration, combined with a hydraulically adjustable log bed, allows operators to achieve cutting accuracy within 1/16 inch, precision that would astound sawyers from the early 20th century who considered 1/4 inch accuracy acceptable.